Electricity is something we deal with every day, whether you notice it or not. Does that mean we are all expected to be professionally trained electricians? Of course not. But there are some things you should know to keep yourself and everyone around you safe. Let's start with some standard terminology used when talking about electrical-related topics. Conductors are materials that allow electricity to pass through with ease, usually metals such as gold, copper, silver, iron, mercury, and aluminum. Water is a great conductor due to the dissolved salts and minerals mixed throughout it. With that being said, the human body is made up of a little more than 60% water, which makes our bodies a conductor as well. Insulators do the opposite of what conductors do. They allow very little electric current to flow through it. Examples include glass, wood, ceramic, rubber, and plastic. This cable has rubber on the outside, an insulator. The inside is copper wire, a conductor. The electricity flows through the copper wire, and the rubber acts as the insulator, keeping the electricity contained. It is important to remember in certain situations, an insulator can become a conductor. For example, a clean, dry piece of wood is an insulator. But if that wood is soaked in water, that would make it conductive. Even a painted or dirty 2x4 can turn it into a conductor. Fuses and circuit breakers are designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. A fuse's essential component is a metal wire or strip that melts when too much current flows through it, thereby interrupting the current. It is a one-time use device. Once a fuse has operated as an open circuit, it must be replaced or rewired, depending on the type. A circuit breaker's basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset, either manually or automatically, to resume normal operation. These devices help protect equipment and prevent fires, but do not always stop people from getting shocked. GFCI stands for Ground Fault Circuit Interrupters. They can also be referred to as Residual Current Device, RCD, or Residual Current Circuit Breaker, RCCB. These are devices that instantly break an electric circuit to prevent serious harm from an ongoing electric shock. Injury may still occur in some cases, for example, if a human falls after receiving a shock. They can be installed in cables or directly into an outlet. They detect any change in current and immediately cut off electricity from that point on until reset. Voltage is the force which moves electrons in the current. 120 volts is found in a typical household. This can be fatal. 240, 277, or 480 volts are considered high voltage. These can be especially lethal. The amount of electrical current is measured in amperage. Amperage, also known as amps, could be considered as one of the greatest dangers when dealing with electricity. Less than 1/10 of an amp can be fatal. Alternating current, AC, is an electric current which periodically reverses direction, in contrast with direct current, DC, which flows only in one direction. Alternating current is the form in which electric power is delivered to businesses and residences, and it is the form of electrical energy that consumers typically use when they plug in kitchen appliances, televisions, fans, and electric lamps into a wall socket. Direct current, DC, is the unidirectional flow of electric charge. A battery is a good example of a DC power supply. Direct current may flow in a conductor such as a wire, but can also flow through semiconductors, insulators, or even through a vacuum, as in electron or ion beams. The electric current flows in a constant direction, distinguishing it from alternating current, AC. In electrical engineering, grounding is the common return path for electric current, or a direct physical connection to the earth. You will notice a ground plug on some tools and appliances. The ground prong is connected to a grounding wire in the cord. If there was a short circuit, the surge would flow through the ground wire into the earth rather than into the person or equipment. Static electricity is the buildup of an electrical charge on the surface of an object. It's called static because the charges remain in one area rather than moving or flowing to another area. We see static electricity every day. It can even build up on us. For example, when we rub our feet on the carpet and then zap something when we touch it. That is static electricity that we have built up on the surface of our skin, discharging onto another object. We also see it when our hair gets charged and sticks straight up, or when our pant legs keep sticking to our legs. This is all static electricity that is built up on the surface of an object. A tiny spark can be extremely dangerous in an explosion setting or area with flammable liquids. During the transfer of fuel or other flammable liquids, the grounding wire is mounted to the container before transfer. This helps discharge the static electricity. There are many electrical terms, but those just mentioned are some of the most commonly used. Now that we have a basic understanding of the terms, let's look at some real-world hazards. You must stay alert when working with or around electricity. Hazards such as loose or missing covers, switch plates, or damaged outlets must be repaired immediately before use. Damaged or exposed wiring is another big hazard. Overloaded circuits is another common problem. Report these conditions to your supervisor to be fixed. If you find any hazards at home, make sure you have them repaired by a qualified technician. Take extra care when working around loose wires in the walls, ceilings, or crawl spaces. It is important to have a work light so you can see what you are doing. PPE is also very important. Wear goggles to protect your eyes from debris, especially when working on projects that require you to look up at what you are working on. Cutting into walls can be very dangerous. There are potentially wires and you could cut into them. You must use a circuit tracer or look at blueprints to determine where wires may be present. If you're going to be working with electricity, it is important that you remove items such as belt buckles, rings, watches, really any jewelry. Make sure your hands are dry when handling electrical cords or equipment. Always make sure you switch the device off before unplugging it. Never use an aluminum ladder. Fiberglass or wood ladders are best to use around electrical sources. However, moisture turns these items into a conductor which can have fatal results. Wet gloves and wet footwear can increase your chances of being shocked. Always keep your attention on the work at hand. Distractions can lead to serious accidents. Always turn off electricity when working on or near wires. Always wear the correct PPE and make sure to use insulated tools. When shutting off the power at the breaker, make sure you use a lockout device to ensure no one powers the area you are working in. Make sure you are authorized and trained in lockout-tagout procedures. Wearing leather or insulated gloves gives you added protection. Use a circuit tracer or meter to verify power is off. When working, make sure you use insulated tools. There is a voltage rating listed on these insulated tools. When using hand tools, double insulated tools will give the best protection. If you need to use a ladder, make sure it is wood or fiberglass, and most importantly, dry. Never use adapter plugs. This removes the grounding protection built into the cables. Again, never turn off a device by unplugging it from the cord. If the device has a power switch, make sure you use it before unplugging. If you ever find yourself in a situation where someone around you is being shocked, follow these steps. Rule number 1, if they are still being shocked, don't touch them. The electricity can pass through them and you can be shocked also. Next, if possible, quickly shut off the power at the breaker and call for emergency medical help. If you can't turn the power off, use a dry, clean, non-conductive object to push the person being shocked away from the source. Keep the person calm and still until help arrives. Do not give them water. Water can cause them to have a stroke. If you are the one that is being shocked and you cannot let go of the energy source, let your knees collapse and fall away from the source. Whether you're at home or the office, electricity is serious business. Take the information from this program and apply it to any task involving electricity. Thanks for watching and have a safe day.